Curitiba is famous for its urban planning and plans, but did not present planning instruments for the mitigation or adaptation of the climatic changes. For this reason, seeking to contribute with an academic vision about the subject, the group of researchers from the Federal University of Paraná in Curitiba decides to lead this investigation. The city has almost 2 million inhabitants and is the coldest capital of the country. Considering the projections from IPCC for this area of South America, the increase in average temperature can reach since almost 1 Celsius degree in winter of 2020 until 4.5 Celsius degree in summer or winter of 2080.
Authors like Ley et al., Mills et al., Endlicher, Kachner, and others indicate strategies such as the change of the urban geometry, the use of cool surface, the incorporation of water bodies, and planting vegetation that can mitigate the thermal environment. The urban climatic map was employed since the mid-1980s in several countries to visualize and spatialize different climatopes. So, the ETSAC map was used to make the characterization of the different climatopes from Curitiba. Also, the creation of two different scenarios from the intensification of streets forestation. Here we can see the process, the input data from land use, land cover, and the digital elevation model. So, in the left, the 4 layers that was input data to the thermal load map, and in the right, the other 4 layers, the input data of the dynamical potentials map. Finally, we have the UCN map from the year 2019. In the local scale, we considered the entire city that we can see in the left picture where appear the axes of public transportation, density, and verticalization that gives the city this tentacular shape. And in the microclimatic scale, we considered 3 blocks of the Battle neighborhood in the right picture. Now you can see in full detail the input data and topics of processing. Here we see the list of input layers from the thermal load map, also the classes in each layer and the weights for each class. Here we see the list of input layers from dynamical potentials map. In the mitigation scenario 1, we choose specific trees used in Curitiba with 18 meters of cup diameter, 15 meters height, attenuation coefficient above 80% to the summer, and apply the main roads and avenues. In the mitigation scenario 2, we added the scenario 1, all the other streets, and we choose specific trees with 8 meters of cup diameter, 10 meters high, and attenuation coefficient above 80% to the summer. Comparing the scenario 1 and 2 with the scenario 2019, the results in table 1, we see reduction in all values from class 4 until class 7. The figure 6 shows only the streets around downtown. Then we see the reduction of values in the classes 5 to 8. Considering the entire city, in table 2, the area of classes 5 to 8 is reduced in 3.3%. And considering only the open spaces, the area of classes 5 to 8, it's less than 12% of all streets, and was reduced in almost 4%.
To evaluate the microclimatic effects, a 3D model using the software EnviMat was simulated. The figure 8A represents the scenario of the year 2011 with only 14% of the land covered surface with urban forestation, and the figure 8B represents the year 2019 with intensification of forestation applied in the 43% of the land covered surface.
We verified in this table 5 the reduction in the air temperature and wind speed, but some increase in the relative humidity, exactly like was expected. When evaluated the thermal comfort, the UTCI index, like demonstrates the table 6, has significant improvement from 6.3 Celsius degree in the medium valley and 8.6 Celsius degree in the maximum valley of temperature. The UCN map for Curitiba was the first map of the climatic analysis to Curitiba and represents the different degrees of the comfort and discomfort in the urban space. The method provides a simple tool to simulate in a simplified way the potential mitigation by the intensification of the urban street forestation. The quantitative results are encouraging, so much for the gains in terms of dynamical potentials, as well for the improvement of the thermal comfort. In considering these results of the microclimatic simulation, it is possible to conceive a UCE remap in which the classes vary from the 1 to 5, being the warm moderate stress the worst class.